If you're finding yourself having a little bit of trouble with your trig graph homework tonight, I'm going to work through the first two examples right now. So if you'd like to look here for any pointers, feel free to watch this video as much as you need to. So here we have a diagram shown below of the graph of a cosine function. I know it's cosine, it specifies that, so I'm just going to bear that in mind if the detail matters later down the line in the problem. And there you can see I have a value, missing value for A, a missing value for B, and for C. We talked about what each of those mean in class today. And they're also telling us that our A value is greater than 0. That's going to help us out. So looking down a little bit into this problem, the point P is pi over 4, 2. It's a maximum. Point Q is 3 pi over 4, negative 4. That's a minimum point. And they're first starting this problem by asking us to solve for the value of A. Remember from class, that's our amplitude. So if you're having a hard time finding the amplitude, just remember there's a formula for that. We take the maximum minus the minimum and divide that by 2. And they gave us the max. You choose the y value because that tells you how high or how low it is along the y-axis. So we choose the y values when we fill into this formula. So we get A, which equals the max minus min over 2, to be 2 minus negative 4 all over 2. This is 6 over 2, or I get a value of 3 for my A value. So that's going to tell us all about A. In part B, they want us to determine the period of f. So this takes a little bit of thinking here. So this is a cosine graph. So let's take a look at what they gave us here. So you can see on your cosine curve that the hill starts here, and this is the bottom of the valley. So all the space between the top of the hill and the bottom of the valley, this would be half of a period for a cosine curve, because you could see it's starting to continue back up. And in order to complete the curve, we would have to go back all the way to the top. So what they're giving us here from pi over 4, to 3 pi over 4, this is half of the period in the x values. So half of the period, I'm going to go back now, so write that on your graph if you need to. Pi over 4 to 3 pi over 4, that's half of a period. So the space that's displaced between pi over 4 and 3 pi over 4, well, that's 2 pi over 4 in between, or pi over 2. So again, this is all half of a period. If I want a full period, I'm going to have to double that answer. So I'm going to have to take this half of a period and multiply it by 2. Therefore, 1 period is equal to pi over 2 times 2, or simply just pi. It's a tough one. So that gets us the period of the graph. In part C, they want us to find the value of B. So if I want the value of B, remember we have a formula where the period is equal to 2 pi over B. B is my unknown. I don't know it, but I do know the period now. It's pi. So I can fill in what I do know. It's pi equals 2 pi over B. When we cross multiply, we get B equals 2 pi over pi. Pi's divide away, and we get a B value, or our frequency of the graph, is equal to 2. The last question, part D, asks us to write down the value of C, given that C is between 0 and pi. So now we're solving for C in this part of the problem. So let's go back up to the equation and see where C was located. I forget its spot. Let's see where it is. So C, you could see, is right inside the parentheses, and that's the location where it tells us phase shift, left or right. So we have to think about where cosine graphs normally start. So normally cosine graphs start on the y-axis at the top. But now what's going on is it's shifted. It's starting its cycle over here at pi over 4. So it looks like it's shifted pi over 4 units to the right, because normally it starts on the y-axis. But now it's starting at an x value of pi over 4. So my C value here for this function would have to be equal to pi over 4 for my final answer. So that's using a graph and relating it into certain parts of an equation. If yours a little stuck still, I'll try one more example on the next page. So if you flip over, I'll do number 2. If not, continue working, keep up the good work, and talk to me in class tomorrow if you have any questions. So in number 2, the following diagram shows part of the graph of y equals p sine of qx plus r. So again, I'm looking at this function and I see I have an unknown value for p. It's telling me about amplitude, something unknown about my frequency, and something unknown about my vertical shift. So obviously they're going to be asking us in the next couple of parts what those actual values would be. So in this problem, they're giving us the max, they're giving us the min, and using this information, we have to come up with the different pieces that make the sine curve special or unique in this case. So they're asking us for the p value, which you could see p is amplitude. So they're asking us for amplitude. They do change up the letters on us sometimes. I know amplitude is usually A, but here they use P. It doesn't matter. It shouldn't throw us off course. So to calculate amplitude, remember again, we do max minus min. Over 2, we use the y values. So the maximum y value is 2 minus the minimum y value of 1. The amplitude here is 1 over 2 when you calculate. In the next part, they're asking for Q. So if you look at where Q is in the formula, because Q is the coefficient of x, they're directly asking us for the frequency of the curve. So frequency, remember, is how many times my cycle occurs between 0 and 2 pi. So the graph they're giving me is only to pi. So whatever my answer is for frequency when I'm counting on this curve right now, I'm going to have to remember to double that. So it's 0 to 2 pi. So if I look at this sine curve from 0 to pi, I can see, okay, here's my hill, there's the valley, that's one cycle. And then the cycle starts over again. So it starts to go up again, starts to go up, begins to come back down, and at pi, it looks like it hits a total of 1.5 cycles. Here's my one cycle. And then this one's not completed yet. This is half of a cycle. So my frequency from 0 to pi is 1.5. If I want to know the frequency from 0 to 2 pi, well, let's just multiply that frequency by 2. We get 3. So 3 is my frequency for this graph. And finally, they're asking for the R value. And the R value, if you see here, the R value is telling us what our vertical shift is. It looks like we're going up. And if we want to figure how far up or how far down, it helps to find the midline. So if you're a little stuck in finding the midline, you could add the max and min and divide by 2. It's very similar to how you calculate the amplitude, or just work from a max. I know the amplitude is 1/2, so the midline has to be there. Has to be even to the minimum. But if that's really confusing you, again, you could always do max plus min. Divide by 2, and you should get the R value. Your shift up is 1.5. All right, so all the rest of the problems in this homework are very similar in nature, so you're going to go through the various strategies that we went through right now. It helps to use a different color pen at times to help you see different features of the graph. Good luck with your homework. Bring any questions in tomorrow.